Hi, welcome to Social Research Insights. My name is Kamaksha Masura. I am Principal Consultant at Social Research Insights. Social Research Insights is not a business organization. It is a freelance training outfit. We are just a couple of individuals who are working on freelance style. We have a lot of content online, and all the content is free. It is absolutely free. However, we would like to make a request. Please consider us calling for some staff development or faculty development programs. We are also available for the workshops, conferences and seminars. We do deal with training related to data analytics, science and IoT. This is in fact one of my presentations which belongs to a series of presentations related to healthcare analytics. In my previous video I've explained how to compute the capability index. The capability index is known as a very important measure that deals with the ability of a service organization. Since we are talking about the healthcare analytics, so I'm going to tell you how to compute the capability index given some healthcare data. So we are going to assume that we have some number of cases for a given month. So obviously we are going to take some 30 data points, and I'm going to perform some statistical calculations so that we'll end up with this particular beautiful statistic known as capability index. Now in my previous video, since I told you how to compute the capability index, in this video I'm going to show you how to compute an alternative to capability index, which is known as CPK. The capability index is referred to CP, and CPK is a special scenario where if the underlying distribution is not found to be normal. So what we are going to do, as usual, as we did in the last demonstration, we are going to simulate some abstract or fictitious data set, because it is not possible for me to take the real-time data sets. If you have real-time datasets, then you can start doing the calculations, or you can contact me. I can help you how to compute the capability index, provided the underlying distribution is not found to be normally distributed. So as usual, I'm going to simulate the dataset. This time I call it as case. I already have that cases 2. I'm going to use 3 beautiful functions available from the R programming language, that is absolute, which is the command name is ABS. This helps us to make the data points absolute values, that is free from the sign. Next, round the values, and I don't want the decimal point and numerals after followed by the decimal point. And I take the data from the Poisson distribution, assuming that it is not normal distribution. Actually, it is a special case of normal distribution. I think the Poisson distribution makes much more sense for healthcare organizations, because we are talking about a day, and where we are expecting to see an expected number of patients. So I think Poisson distribution do a lot of justice to this particular scenario compared to the normal distributions which we used earlier in my earlier demonstration. I'm going to request 30 data points to make sense for a month, so that as if we need to assume that we are analyzing some 30-day based data, and I'm going to make an assumption that I'm going to take values around a particular average called 50. You just have to study something about the Poisson distribution, which is one of the important probability distributions in the theory of statistics. This is called lambda value. So I'm requesting our programming language to generate 30 data points from random points. R stands for random, from a Poisson distribution using an average value 50. So whatever the set of values that we are going to generate will be around this 50. And now I am trying to multiply with 10 so that the value looks so nice and meaningful for the analysis, and round it to 0. Now since we already executed the statement, let's go to the console and see what are there in the cases 2. Yeah, that is okay. I think cases 2 we still have let me take 10 instead of, so that the average number of patients who are coming to the hospital, who has undergone the treatment in the hospital. And now let's see cases 2. Yeah, this time it is okay, but I'm not happy with 50. 10 is okay. So I mean, I'm just trying to make my data comfortable for the analysis, but your case will be different. You will be having the real-time data, but the data will be I mean, more or less same. That won't be. Let me convert into data frame, and let us try to understand more about cases 2 as data frame cases 2. Now edit cases 2. Yeah, so the hospital has treated 80 patients in day number 1, 100 patients in day number 2, 120 patients day number 3, 120 patients day number 4, something like that. And we also have, I mean, the 13th day of the month, some month, it is January, February, March, let us not 90, 70 and all. In case if you want to go for the summary statistics, you can also do that. If you go for the mean, cases 2, then you have 107. This is not that mean, that is the Poisson distribution. This is arithmetic. This is arithmetic mean. This is not the mean for the actual mean for the Poisson distribution is 10. So let us go for the normality check without much ado. Then in which case I have to I'm going to tell you how to check the normality as usual, as we did in the last demonstration. We have a beautiful function in R programming, that is histogram. This is one of the techniques, belongs to visual investigation. SS2 frequency, I don't want the frequency, make it false. Then press enter. We have, yes, of course, it seems to be abnormal. It's not normal, like I don't know whether I can call it as, but non-normal something. Lines density cases 2, then make color as red so that it looks distinguished. You can use any color, green, gold, whatever it is. Now you see the underlying distribution does not seems to be normally distributed. So this, but however, we did not change the x values. This is not visual investigation reveals me that the underlying distribution is not normal. So we can go ahead and compute the CPK, not the CP. Okay. CPK is actually a peculiar statistic, which is an alternative to the capability index when the underlying distribution is not normally distributed. So for CPK, let me explain you the methodology. Just like CP has got some formula. The expression for the CP is the difference between the upper specification limit, something like that. I explained all these methods in my last. Now in this video, I will explain you CPK, which is a capability index following the assumption that the underlying distribution is not normally distributed, is equal to minimum of C upper comma C lower. So this is, I'm sorry, I'm not good at. So what is this C upper and what is this C lower? These are the capability indices around a particular specification. For instance, when I talk about the C upper, this is the ratio of the difference between upper specification limit and the average, the arithmetic average of the distribution over 3 standard deviations, and both standard deviation and mean are the hat values. And these are the expected, these are the values which are connected based on the sample information, but not from the population. And you see here actually we have a distribution, a normal distribution, where we have USL, this is LSL, lower specification limit, this is USL, and somewhere we have the mean. So the C upper is a value that which roughly falls between the mu to the upper specification limit. Since the upper specification limit is the maximum compared to bigger than the mu, so we are going to deduct the mu from the upper specification limits, not the other way around. Now coming to the C lower, so we need to calculate Since the lowest specification limit is the lesser value lesser than the mu, then we need to take mu minus LSL, lowest specification limit, divided by 3 times standard deviation. So we need upper specification limit, lowest specification limit, and mu, and both mu and standard deviations are the hash values. And then finally we'll decide the minimum value, and that value would serve as the capability index for. Why do we consider the minimum value? That is the most important aspect when we speak about the healthcare analytics. Generally, when we talk about the capability or maybe the efficiency, strength, and etc., we do talk about the. We always like to make the gesture, or like to make the the inference based on the minimum possible value, not from the maximum possible. For instance, let us take a household who would like to plan for the monthly budget, and the calculations will be made based on the minimum capability of the household earning, but not on the maximum. It is the worst possible scenario that we always try to keep when we are estimating the future events. So that is actually the human psychology. Not only human psychology, it is a systemic thinking. So we always try to keep the worst scenario instead of the actual and best scenarios whenever we try to make a strategy for future. So in the same fashion, the reason behind choosing the minimum possible value for the capability index is to consider the worst possible scenario to evaluate the capability of the healthcare system. Okay, now let us jump into the action without doing much ado. So we need certain basic or standard values, that is the mean, standard deviation. So what we do, C mean, I call it as C mean, and instead of calculating the mean using the function and all, it is better to make an object, user object for the mean of the cases 2, and C standard deviation is standard deviation of the cases 2. And now go for the upper specification limit. As you remember, in my previous demonstration I explained what is upper USL and LSL. Upper specification limit is the upper limit of the confidence interval, and lower specification limit is the lower limit of the confidence interval, and upper limit of the confidence interval is the mean, here in this case C mean, which is the user object, plus a Z value 1.96, which is a threshold value for the standard normal value at a 95% confidence level, which means that we are assuming that we don't have the objection to infer the values at 95% confidence level. Multiplied C, I think here we need to make here we need a standard error, not the standard deviation. C standard deviation divided by square root of length of cases 2. This particular part of the formula is the standard error, just like in my, you just have to go to my previous demonstration where I explained the standard error is actually the standard deviation divided by square root of n. So this is what I'm trying to do here. C mean x bar, so upper specification limit is x bar plus Z sigma E. It is not sigma E actually, SE, which is standard error. So standard error is, this is the way to compute the standard error, and 1.96 is the Z value. Let me press enter. I think there is a problem. This is the C standard deviation. CSD is the standard deviation. Yeah. Now let me copy the same value, and I change the, instead of upper I put it as lower, and now the sign need to be changed to minus instead. This is the lowest specification limit. Now we got the USL, and let's go to the console and press USL and LSL. So okay, that both of them are positive. Now let's compute the CPK. We need to go for the C upper, which is going to be like this: USL minus C mean divided by 3 standard deviations, which is CSD. 3 multiplied CST. And C lower is going to be, we just have to change this formula. Instead of deducting the mean from the USL, we deduct the LSL from the mean. And the reason is very simple, sir. Let me tell you that again. How are you going to solve when you add C, as I said, CPK is going to be minimum of C upper and C lower. Why? Because we are going to one of the reasons is that we are going to exercise the worst possible scenario instead of. Now when we solve these two expressions, C upper is going to be upper specification limit minus mu by 3 sigma plus upper mean minus LSL by 3 sigma. Now let us take the LCM. 3 sigma USL minus mu plus mu minus LSL. Now plus mu minus u cancel each other, then we are left with USL minus let me put it here, USL minus LSL by 3 sigma. So indirectly what we are trying to do, we are trying to find the capability index at 3 standard deviations. So instead of earlier we calculated this at 6 standard deviations, but this time we are calculating at 3 standard deviations, so that we are just restricting the capability index to the 3 standard deviations. But anyway, the expression is quite similar to the expression that we had done earlier. This is the logic behind choosing behind choosing CPK in lieu of CP. So when we are calculating the CPK, it is none other than CP. So we are not far away from the concept of the CPK as far as the statistics are concerned. So now let us go back and calculate the CL, and now CPK is going to be one of the minimum values of CU and CL. So now let us go to the console and check the values CU, C, and now CPK. Oh, that is positive, right? 0.1192. Now how are we going to interpret the value? That is very, very important for us. The interpretation of CPK, which represents the capability index for a particular scenario where the assumption of the normality is violated, as we are seeing at the graph. Some industries would expect that the CPK must be at least 1, not the utmost 1, just like CP, at least 1. And moreover, it is better if it is positive, not negative. But it is not a common observation across the industries, and some industries will try to have their own threshold value for the CPK, just like Motorola, which is one of the world-renowned company that very adamantly follows the Six Sigma philosophy to the core. They believe CPK, a minimum value of CPK, to be 2, not 1. But in most of the industries, to demonstrate the capability in a particular given service, area of service, the organization or the system need to have at least 1, possibly positive, not the negative. So this how, well, in this case, this 30 days data related to a particular hospital. The hospital has a positive capability. I mean, they have a capability, but however which is not sufficient. They failed to achieve the minimum threshold value for the capability index, which is 1. Okay, this way we can compare the capability index under 2 different circumstances. I explained the capability index, calculation of the capability index when the underlying distribution is normal, and also the calculation of capability index when the underlying distribution is not normal. I think this is sufficient for this particular concept, capability index, which belongs to an area of operation called quality management in healthcare industry. I'm sure you like my video, and if you like my video, please press like, and kindly don't press dislike or unlike. Stay tuned for subscribe to my channel and stay tuned for the new content. Thank you.